Greetings, this is Mrs. Ellsworth. Look at that. Arnold Palmer iced teas. When I used to waitress, we would we'd have to pour very carefully the tea on top of the lemonade so that it would stay on top. And people loved Arnold Palmer teas where I worked at. Tea is less dense than lemonade. Why do you think that is? Well, lemonade has to have a lot of sugar in it to make it good, and that makes it more dense, and so it'll be at the bottom. Let's look at this. Why do you think I'm bringing these two salad dressings into this discussion of density? You're going to have to bring this answer to this question to your group, and we're going to be discussing it in some detail when we return. So that's your question you'll be coming back to the classroom with. Well, let's start out with the density formula again. Density equals mass divided by volume. So how are we going to find that mass of a liquid? Then we'll worry about volume. Well, to find the mass, you've got to tare the balance with the graduated cylinder on it. And then once you tear it, it's at 0. So now when you take the mass when you pour your liquid in it, you won't be taking the mass of the graduated cylinder also. So you don't have to do any subtracting. The balance does it for you. So that's pretty cool. So you tear it when it's empty on the balance. Then you add your liquid to it, but please do not pour over the balance. Save the life of a balance, please. And then you quickly put it back over it and before the light goes out on it, and then you can read what the mass is. Read the mass straight. That is what your volume will be, what your mass will be. This one is probably my favorite one of all the densities to do, and I know that you probably think that I'm crazy about that, but now when you try and find the volume, you're going to be amazed at how simple it is. So we found the mass. Okay, let's say on the balance it read 67.8 grams. The volume is so nice. I mean, this is where finding density of a liquid is so exciting, and I am not kidding. Just read the volume on the graduated cylinder. That's it. But don't forget your units. I don't think that I have any units on this whole section of your lab, so really be thinking about your units as you do them. Okay, so you'll just eyeball that, get your eye at the right level, read the bottom of the meniscus, and in this case, the volume is going to be 80.6 milliliters. So the density would be 67.8 grams divided by 80.6 milliliters, and you get 0.84 grams per milliliter. Now, there's something important about that. What do you think that is so important about that? That density is a small number, and why do you think that that is important? That means that this liquid is going to float on top of water. Remember, the whole metric system is based upon, well, the units that we're using is based upon the density of water being 1. So, since it's less than 1, that means that it will go on top of water. It will float on top of water. It's less dense. Okay, but you can always check your work. That's the cool thing about specific gravity in our class, because I'll have 2 big, huge graduated cylinders up in front of the classroom, and then you find the specific gravity and check to see if yours are right. Instead of coming and getting your answers from me, you're going to have to go find them yourself. I will help you read it if you need help, but here's some ideas on how to read the hydrometer. Okay, specific gravity, first of all, let me tell you what it is. Okay, it's a ratio between the density of a liquid that you're testing and the density of distilled water. With metric units, it is so nice because the density of distilled water is always 1. So you're dividing it by 1. Okay, so we use these to measure only the densities of liquid, of course, because it's the density of your liquid and water. They're both liquids. Anyway, then we're going to have grams per milliliter for a unit over here, grams per milliliter for a unit down here, and they both cancel out. So specific gravity is a true ratio that has no unit. Did you hear that? Specific gravity has no unit. If I was going to say that the density of this substance was 0.84 grams per milliliter, the specific gravity would be 0.84 and no unit. Exciting, huh? Okay, so, oh, I just answered that. It's just amazing. Anyway, for reading a hydrometer, what we've got is a big, huge graduated cylinder that is filled up with the liquid. We'll have liquid A and liquid B at the school. And here's a hydrometer that just sits inside of there and floats. Sometimes it goes and adheres to the side of the graduated cylinder. You just have to kind of move it off to the side, and you'll just have to read the bottom of the meniscus just like you do on a graduated cylinder, but it's a little bit more difficult to read. And also they're harder to read because they're handwritten from Germany. These are really old hydrometers that we have to be careful with. In Germany, their commas are periods, and their periods are commas. So you got to watch out for that. What you think is a comma is really a decimal on these. So I'll help you read them, but usually when we get a few pairs of eyes on them for your group or your teams, then you can pretty much read them yourselves. And don't forget, specific gravity has what kind of unit? No unit. Okay, here's what one looks like, except for I don't like this. This must be a really heavy metal or a heavy liquid type one that should be going... I don't understand it. The water level should be up here so you can read the graduations on it. But this is the only one I could find that was inside of a ungraduated cylinder so that you didn't have other lines messing with it. So you can use specific gravity to check your work. It's just hard to read sometimes. And that's the density of liquids. Short and sweet. See you tomorrow to do this lab.